So you dealt with equations that were in a squared form. So now these are going to be equations with different sorts of radicals going on. Alright. Free fall height. Two objects are dropped simultaneously, meaning they're being dropped at the same time, but not necessarily based on that sentence from the same height. The first object reaches the ground in 2.5 seconds, and the second object reaches the ground 1.5 seconds later. From what heights were the two objects dropped? Okay, so if you really wanted to get organized, I'll make this optional. You could call it first, and then second, and this is not first and second order. This just means the first one that they mention and the second one they mention. And as I've usually encouraged, I think it's a great idea to rewrite whatever formula they give you. Now in this case, it doesn't say we're going to be memorizing this one, but this way I can nicely plug things in. So the first object reaches the ground in 2.5 seconds. So I'll write 2.5 equals the square root of h over 4. There's nothing really weird going on. There's no addition or anything inside here. There's no addition outside either. So I think this is going to be mostly straightforward. And then 1.5 seconds for the other problem, square root of h over 4. In solving both of these, it's like you're going to multiply both sides by 4. 2.5 times 4 gives me 10 is equal to the square root of h. And then I have to solve this by getting rid of the square root, so then I'll write h is equal to 100. And since we're looking for units on this, I'm not seeing anything about... Okay, so I'm just going to leave this as 100 feet. Why not? I normally wouldn't do that, but I think that this one, maybe I forgot to put something in the notes where it made it clear when I took this from a textbook. So then I'm going to have the same deal over here, times 4 times 4. 1.5 times 4 gives me 6, is equal to the square root of h. And then I'm going to take that, square this as well, and then I will say h is equal to 36 feet. Now, with both of these, there's no need to use approximate symbols or anything like that, because these were equal. From what heights were the two objects dropped? And then if you wanted to summarize it, optional, you could be like, they were dropped from 100 and, sorry about my handwriting here, 36 feet, respectively. And this should make sense if I do a simple check on this, and here's what I mean by a simple check. If this one took 2.5 seconds and this one took 1.5 seconds, then our first answer, because of the larger time, should be a larger answer. At the swim meet, Brandon dived. If you want to try this one on your own, that's cool. Brandon dived off 2 platforms at different heights. On the first dive, it took him 78/100ths of a second to reach the water. On the next dive, it took him 1 43/100 seconds to reach the water. How much higher? So now instead of the previous problem, where they just wanted it stated separately, it sounds like we're going to have to do some comparison. So that means there's going to be an added step at the end. And it looks like this equation is going to show up again. T is equal to the square root of h over 4. And since we're dealing with decimals in this one, I think we're going to end up with decimal answers. Okay, so in the first dive, we will write 78/100ths, or 0.78, square root of h over 4. And in the other one, we'll write 1.43 equals square root of h over 4. One of the reasons I do this all in one step is because it kind of keeps it clean. Meaning I've organized my work. It's not like I'm doing times 4 and then jumping over here to do times 4 and then back and forth and back and forth. The only reason I'm plugging in the variables right now and getting the equations down is I'm mapping out my problem. 3.12 is equal to the square root of h, and then I'm going to square this, and let me type that into my calculator. I get 9.7344. Now it doesn't tell us to round or anything, but that's pretty excessive, so I'm going to stop this at the hundredths place. So I'm going to write h is approximately 9.73 feet. You know, maybe I box it, even though that's not my final answer. Over here, multiply by 4. Let's see, 1.43 times 4 will give me the square root of h is equal to 5.72. This time I flipped the order, it doesn't matter. Squaring that gives me 32.7184. So again, I'll take this solution and I will round it to approximately 32.72 feet. You know, it's nice to do these in one step and not use rounded answers, but I think for the sake of this problem, I will use the rounded parts. So I'm doing 32.72 minus 9.73, and it's a good idea to write that down. And then I'll have an answer of 22.99 feet. Let's revisit the final question. How much higher is the second platform than the next? So since this one was this high and that was that high, you can just find their difference. Okay, I thought this would be a good cutoff point for this video because these are the real-world intro problems, just to kind of show what they mean by having variables in the radical. And these have been done before because you've had to square to get rid of a radical. Pay attention to your units. I don't have many more tips to give. I think these first couple ones are straightforward.